The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, maybe good morning or good evening. Welcome back to Areopa webinars. It will be number 72. Yeah, the number is growing and growing. Of course, after 5 years or almost 5 years, it's quite a number of webinars that we performed last years. Today, my guest is Xavi Ametller. I might pronounce it a little bit wrong, but Xavi is a former colleague of me at Microsoft, and ever since then a close friend. We're not daily discussing things on tests, but surely once in a while, and surely when I wrote the second edition of the book, I was very pleased that he accepted my invitation to be one of the reviewers to the book, and at that time we had quite a number of discussions. I asked him or offered him to come up with a webinar, and I'm very pleased with this title also. And one of the reasons to ask Xavi is that he has been continuing to work with testing, but also as a developer working on testing and doing things test-driven development way. So today he's going to share some of his thoughts, and in a way also going to challenge me and others to come up with questions to challenge what he's coming up with. Well, I'll leave it to him to, of course, tell the story and give a little bit better introduction on himself. But before I'm going to hand over to you, Xavi, and very welcome to be here. I'm going to go through a couple of slides, like always, on, let's say, housekeeping rules and other things. As most of you probably know, and if you're new, your microphone is muted. You cannot unmute it. So what we do is we use the GoToWebinar question window. I think you can find it in your control of GoToWebinar. And I am the moderator, me, Luc van Vugt, will pick up the questions and post them to Xavi where they make sense. Probably if you have a question directly relating, I will post it more or less instantly, and otherwise it will be at the end of today's webinar. So be pleased to step in, be more than welcome to do that. And of course, this is being recorded, and I'll do my best to get this on our YouTube channel as fast as possible. If you're not yet subscribed to our newsletter, feel free to use this very descriptive URL, but I think while I'm talking, you could already put it in your browser and get it opened. And of course, looking ahead, I think there's something not changed in the date here. I now see this should have been October 9 because we had to reschedule, and I think I totally missed this while I was editing this slide. So next week, Shannon will do her webinar, which was actually planned 2 weeks ago, but as she fell ill, it was of course not possible to run it. And on October 16, Tina will be doing his webinar on, let's say, connecting to APIs in a secure way. October 30, that's also a rescheduled webinar from Arjan Kaufman on external business events, and a new one has been scheduled with Waldo on December 4. There probably will be some others planned in between, which I'm working on, but not yet set. So the list is here on the website. If you follow the URL here, you will find the links for registration. And before I'm going to hand over to Xavi, I always have this call to everybody: come up with any topics, or if you want to be a speaker. And of course, thank our sponsor ForNav for enabling us to do this. So Xavi, I'm going to make you presenter, so you will be able to share your screen.
Okay, hello everyone. Trying to share screen. Can you see the
Yeah, I
slide?
can see it. So
okay.
I reckon that's applicable to everyone.
Good. Okay. Well, thanks a lot, Luc, for inviting me here, and of course to ForNav for sponsorship this, for sponsorshipping this session. So Today I'm going to be talking about how tests can be seen as bets. As Luc said, I'll be happy to tackle any comments or questions that appear during the session, or postpone some of them if they are not related to the topic at hand. So I really encourage everyone to contribute and use the chat. And I'm going to start with a little bit of a history. So where does this talk come from? And it comes from these initial conversations with Luc some months ago, like, would you like to come, and what do you talk about, and what would be an interesting topic? And I've been far away from the Business Central world so much that I still call it Navision or Dynamics NAV. I left Microsoft in 2010, more or less, and I never came back to NAV, except for some sparse discussions with Luc mostly. And we agreed that testing could be an interesting topic because there's a lot of common ground in the rest of the software development world. And at that moment in time, I was reading a book, How to Measure Anything, by Douglas Hubbard. And that book is super dense and super interesting at the same time. I think I'm grasping half of the concepts at much out of that book, but still I'm enjoying the reading a lot. And in the book, the author talks about the fact that all the things that we do in our life are bets. And I was like, okay, if everything are bets, then tests are bets as well. And I collected some of the ideas of the author and tried to map them to the testing world. And I think the metaphor holds, and it's an interesting one to have some conversations, especially on when do we stop testing, how much do we test, or why do we test in the first place. With that small intro, I'm going to be talking now about the first experience I had with automated testing. And you see in the screen, there's a can of Pringles, and you may wonder why. Because I had a Pringles moment when I started with the automated testing. So when I started developing software, I was testing manually. So I was developing a bunch of code and then starting my solution and clicking here and there and putting some inputs and then checking if the answer was the one that I was expecting or the behavior. And that was error prone, tedious. I was not retesting a lot of things, blah, blah, blah. And at some point, I discovered about XUnit or the unit testing frameworks. And that was like magic moment. And then I picked up some code and I started adding tests for that code. Of course, it was a kind of simple code because I didn't know about mocks or anything like that. So, and I started creating tests like crazy, one after the other. And this was a Pringles moment for me. It's like I couldn't stop creating tests because they were for free. They were like, I copy this and I change the input and I also testing this and I can also test that. And it was like awesome. It was hard to know when to stop. And after a while, I discovered that it's good to know when to stop because at some moment your tests starts hurting you. The return of the investment of the test lowers over time somehow. And that's when I started to think about this question. And after that period where I was trying to find the right place for the dial of unit tests, I started to extend my testing experience and the kind of stuff that I was testing. So all of a sudden, I didn't have one single dial. I had multiple dials that I didn't know, or I had to learn where to stop shifting them. And that was for load testing, for integration testing, end-to-end testing, and a lot of stuff that could be automated or other times manually executed. Also, observability is part of testing for me as well. So like you can observe a lot of things. You get into New Relic, Kibana's Logstash, and it's like the amount of data you can have there is huge. So it's like, what should I log and when and how? So this became a recurring question for a lot of topics. And from 1 year now, I've been coaching teams, and looks like I'm not the only one who's having this question, because I'm being asked that a lot of times and in a lot of contexts. And the answer is, as usual, it depends. Hopefully, I will give you some criteria today so you can make your own assessment. And I recall a particular anecdote for my time when I was growing in this regard. And I linked that to Luc in a sense, because that was when I was trying to get hired in Microsoft. I recall having an interview with the director of test, and he asked me a question. It was like I had a whiteboard, and he gave me a marker, and he said, write me a function that, given the hour and the minute of the day, tells us the angle between the brackets of the clock. And I wrote that function with some mistakes that I could fix. And after that, he told me, okay, now write me the tests for that function. And I was like, ooh, I can start writing lots of tests. And I wrote some, and at some point, in a little bit of a bold move for what I was used to, I turned back to the man and said, hey, I'm sorry, but I always struggle with this. I never know when it's a good moment to stop testing, because tests are for free, but at the same time, they come with a price. And he was like, yeah, it's a good question. It depends. I don't know. If you find a lot of bugs, maybe you should continue testing. But if you don't find bugs, then I can feel more comfortable, and then I stop. And I had the conversation that for me was like a very settling, pacifying. Like it gave me peace of mind. Is that person was making, with a lot of experience, was making a set of reasonings that would resonate with me, and some of the ideas and the concerns I had about how to stop testing. So that was an interesting moment for me, and aha moment. Okay, so how can we try to deal with this question? Well, making a step back first. In order to decide if we want to test and how, I think we better discuss about the value of a test. And the value of a test, before having that conversation, I think it's interesting to stop one moment and try to answer this question, okay? So if we create the test for a code that has no bugs, and you will never refactor, and no one will ever read it, and the feature will never be used by anyone, what is the value of that test? Okay. Of course, it depends on maybe some other factors, but in a bunch of contexts, for me, the value of that test would be 0 or close to 0. So if we are never touching or using some code, and nobody needs to understand or refactor that code, and we never run that code, the fact that the code has no bugs in the first place is not important anymore. The code is not being used. But if it's ever used, I've been working with code that's kind of legacy. It's like battle tested, and nobody dares to touch it. And we do not add tests over there, because we also do not have the necessity to change that feature. Okay, so sometimes a test can have no value. When does the test start to have value? Well, I try to make a taxonomy of things that give value and things that decrease the value of a test. I will start talking about the ones that increase the value of the test. So the biggest value we usually seek on a test is to defend some value. Okay, we are creating some code, some feature, because we want to provide value to our users, and to our company. So we want to make someone happy, so they use our product, but also we want to make our company happy, so they win enough money to continue. So we create the test to be sure that the value we're adding or trying to add is there and can be used. All right. So when a test helps us finding or preventing bugs, has more value. If the feature is critical, or if the feature is used by a lot of users, then also the value of the test is increased because we are defending more value. Yeah. I would say, let's say, try for every single box here that you find. If you are in front of two tests and one test give you the same exact value for the rest of the boxes, but tests a feature that is more critical than the other, then if you had to choose one, you would choose the one that tests the feature that's more critical. Okay, and I will try to make the same rationale for the rest of the boxes. A test is defending the value better when it's replicating the behavior of our users from a closer, let's say, point of view from the user. If we mimic things as the users do it and we fail, then we know that users cannot do things. If we do it in a way that users are not doing it, then we know that in that way it can be done and it works, but we cannot be completely sure that the users can do that. And another things that gives more value to a test if it makes it easier to find the bug when the test breaks. So if you find a test that when it breaks, you need a couple of days to find out the problem, it's less valuable than a test that after you do it and it breaks, you can pinpoint the place where the problem may be laying. Okay, so that was for the value. If we go to the second box out of the blue ones, the value of a test increases the more times we execute it, because the more times we are ensuring that the value is still there, and probably the feedback loops are shorter. This box can be easily mapped into manual execution versus automation. If I create a test that requires manual execution, then it's less valuable than if I create the same test and I automate it. Then thanks to the automation, I can execute it a lot of times for the same price. Well, some infrastructure, but it's negligible. If the test supports refactoring, it's also a test that will give us more value over time, because we will be able to work and change the code and improve the code with confidence. And the last thing, if is a test that is on a feature that we will evolve over time. So if we create a feature and we close it and it's done, it goes into the cupboard and we never touch it again, we will have less value out of a test that when we go and work with that feature and extend it or change it, gives us feedback about the fact that we can or not break something new. So those are all the criteria that, in my opinion, can help increase the value of a test. Now, let's go and take a look at what are the things that can decrease the value of the test, or that when they are there, the value of the test decreases. The first one is pretty simple, is the time required to create it and to execute it. If I can build the same test in 1 hour or in 1 day, well, I will choose the option that takes me only 1 hour. So the less time it needs a test to be created, the less investment you will have to do in something that's not adding value. What gives us value is executing the test and the information of executing the test, but creating the test is not, let's say, adding value per se. It can add some extra value if you TDD and you find flaws in your design and so on, but if it's very tangential. The time to execute it. If I have a test that's very fast, I will probably execute it more times. If my test is very slow, I will be more lazy about executing. And even if I am not more lazy about executing, I will have a feedback loop that takes more time, and I will lose more time because of context switching or waiting time or so on. So reducing the time it takes us to create and to execute the test will be adding us value. The next big thing that decreases the value of the test, it's its fragility. If your test is fragile, it may mean that when you change an unrelated feature, you have to update your test because it doesn't compile or it breaks when it shouldn't or wherever. But this work is, let's say, waste from a lean point of view, because you're not adding value to your users or your customers. You're just updating your ecosystem so it displays you the right thing. And the other thing is that when it breaks when it shouldn't. So a false positive, it's one of the worst things that can happen to a test, because you start looking and you cannot find, and now it works and now it doesn't. So tests that break when they shouldn't have less value than tests that are, let's say, repeatable/reliable. And the last box, I think it's quite important and maybe a little bit less obvious than the previous two, is the overlap with other tests. A test can have a lot of value, but if we have 3 tests that are checking the same thing, then maybe some of those tests are redundant. And those redundant tests, well, it took you time to create it, and it takes you time to execute it, and you will have to maintain them, and so on and so on. And I think it's an important box also because of the fact that a lot of times this is the criteria we use to stop testing. Like, okay, I'm not creating another test because I already have these 2 tests that are covering this. So I think it's important that we are aware of the fact that we are using this as a criteria, and also that this is a, let's say, dynamic criteria or a contextual criteria. The time required and the fragility of a test may be, let's say, independent of the other tests. So looking at that test, you know, how long did it take you to create it, and how long does it take in the pipeline to execute it every time, and if you will have a maintenance or if it's break when it shouldn't. But this overlap with other tests, it really depends on the other tests. Depending on what you have, you would be adding a test. Depending on what you have, you would be removing that very same test. Okay, so after going through all these criteria that we could use to decide if a test can get, let's say, better or worse or more or less valuable, we have a cloud here in between, and I think it deserves an explanation, and that's the cognitive load. Sometimes cognitive load is, let's say, reduced by a test. Other times it gets worse. And that's why I put the cognitive load with a cloud and with a question mark. If a test helps me understand a domain and doesn't come up with a maintenance cost, and it saves me time to go through the code to understand what something it's doing, in general, I would say that the value of that test is that test is helping me, is adding me value because it's reducing my cognitive load. On the other hand, depending on how you build the tests, sometimes you will find tests that are misleading, that do not really help you understand the feature, or that just add a lot of more code, which some tests are very verbose and you really have to read them 3 times to understand what the hell is going on there. When that happens, the cognitive load, it's just getting worse. So you have more cognitive load, and that's because of that test or that set of tests. And hence, they are, let's say, making you have to work extra because of their existence. And those kind of tests are, let's say, having lower value than the other way around. Okay, that list was very long and a little bit tedious. I tried to map some of the items of this list into very simple charts. And here you have the first one. If we have on the vertical axis the value we are given by a test, and on the horizontal axis the time. And this chart, let's say, compares a manual test to an automated one in the CI. The manual test is giving value the moment we execute it, and the one that's automated is making sure that that feature is working over time. So we're, let's say, extracting value out of that test over time. The next criteria, well, is the usage of the feature. Yeah, if we create tests for a feature that's not used, the value is kind of negative in a sense that we are working to demonstrate that something that we are not using is working. There's no point in demonstrating that because nobody will be using that, but that's something we don't know sometimes. And the fact that we used that time to create that test and not work on something else means that we lost some value because we could have been adding value somewhere useful instead. Asking ourselves if we're testing the right thing right is kind of this chart. I don't know if you've ever seen a test that has, I don't know, 10 lines. And on the last line, it says assert true equals true. I've seen that in production. And the value of that test was negative while it was in this state over time, because we were misled by that test. We thought that that business logic was covered, that that thing was working. We were making changes, and only until we realized, hey, we don't understand how this test is still passing. This should be broken by now. And we found out about that assert. It was like, oops. So it made us generate waste. So I think it's a reduction of value or a thing that can reduce the value. If we compare a test that's exercising a simple feature versus a critical or a complex one, I think both apply. The tests that work on the critical or the complex feature give us more value. And the example here is, I don't know if you work with .NET or with a lot of object-oriented programs. When you have classes, sometimes you can have properties or similar, or stuff that receives similar names. And the property is just sometimes a getter and a setter, a code that stores the value, and then when you ask for the value, retrieves the value. That test is checking a feature that I will hardly break. So it's giving me not a lot of value. If on the other way around, I have a test that checks that when I'm making an order, I am billing you the right amount of money and I am paying the right taxes and so on, when I break that test, I will run way faster. And that's because that test is defending more value, so it's giving me more value. Also, something similar goes for complexity. If you have a super complex algorithm, then I kind of need the support of tests to know that I'm not deviating from the expectations. So those kind of tests would be giving me more value. How can I model the refactors? I came up with this idea. So in general, the test has the value of the feature we are defending. But if I come up in the future and start to change my code, sorry, if I start to change my code because I want the same behavior, but I think I can simplify it or I improve the performance and so on, then during the periods where I change my code, that test is adding me more value because it's empowering me to make those changes with confidence. And sometimes you do not undergo one single refactoring. Sometimes you go through more than one. So that spike in value for the test can happen more than once. And the next diagram is about the moment when we do create the test. So that's very, let's say, straightforward. If I create the test today, I start to reap the benefits of the test today. And if I create the test tomorrow, I will have the value of the temp test, but for 1 day less. And that's what happens when you do TDD versus test after. When you do TDD, the first thing you do is you create the test. And even if the test is raking, you're still reaping benefits out of that test because you know when you go to green and you have a direction and you have the test as soon as you can have it. When you test after, you maybe like 1 or 2 or 3 days, depending on how big is your slicing, working without that feedback loop. And on top of that, if you build your filter in an incremental way, then your test will get green kind of soon with TDD, or at least one at a time. While if you test after, you start reaping those benefits afterwards. Okay, and the last example of this, let's say, line of thinking would be the moment we receive the feedback. We can have leading and lagging tests. And a leading test is like giving us the information before we have the problem. This would be a test that we put in the pipeline and prevents us to merge pull requests, for example, or even to make a commit. We are not in production yet, and thanks to the test, we realized that we don't want to go to production. A lagging test would be something that we run after we are in production, or that like observability, that after we are in production, we realize that we are already have introduced the problem. So if I can come up with the same test to check the same functionality, and one is leading and the other one is lagging, I will opt up for the leading because I want the information as soon as possible. That test is giving me more value. Okay, so after all these drawings, we see a lot of things that add or remove value to a test, and in general, we combine them. It's not that we live in isolation in, is this a leading or a lagging test, or I am gonna refactor this, yes or no. We do not know a lot of those things. So how does it go? We create a test, we make an investment to create a test, we start putting that code into production, we exercise it, and in this example, if we refactor, we have a spike in value, but then the filter is used by less users, so that means that that test is defending less value for us, even though it's still checking the same filter. And maybe you see the red spike at the bottom right corner. We introduce a new feature, and because of that, we have to change the test. Well, that test became a burden to introduce that feature, because that means extra work that we wouldn't have to do if we didn't have the test. So this kind of price and set of criteria, they all combine in the real world, and it really depends a little bit the value you extract on the test of how things go. And if you look about the list, a lot of things are about the filter. How many times are we going to run the test? How many refactors will we do? How many users will we have using this filter? Are we going to create a test that's fragile? You never know when you create it. You always think it's not, but reality always comes back to surprise you. How much overlap will we be having with all other tests? We have some leverage on a lot of those criteria, but we do not have full control. So that means we're making a bet in this regard. And that's a little bit the idea of tests are bets. Any questions so far? I think it's a good moment to stop if you have any and ask.
Well,
otherwise,
I made some
look,
notes.
yeah.
Nobody came up with a question. Doesn't mean that they can't. I made a couple of notes. I really like the idea of making aware, explicit of the value of what you're doing. Actually, what is your test adding as value, or in what way are you adding value? I have never thought of it explicitly like that, although it relates to quite some things I'm doing. But let's say more or less it's something internally in me as criteria to look at the test effort we're doing. Do you use this explicitly in reviewing things? Are there things that you already made kind of objective, like, oh yeah, this is clear, this is going to add too little value because of this and this? Are you explicitly using this in evaluating the tests?
No, not explicitly. So I think I'm doing a lot of this implicitly. And maybe after drafting this presentation and thinking about this topic so much, I will start to do it in the future. Who knows? But no, I wasn't. So sometimes it's like, it's kind of obvious. It's like, this feature is so simple, I don't think it's worth testing. Yeah, I had this conversation a lot of times. It's like, if I don't have business logic in the code, I hardly wanna test that part. Yeah, because if you don't have ifs and elses, or I don't know, a structure that's doing something slightly complex, I think it's not worth. And maybe that was the way I was stating, and now I kind of formalized it a little bit. Or also the refactorings, I do not have that conversation that much, in the sense that I try to do TDD, and we will see afterwards in one of the slides that TDD takes care of a bunch of these criterias. But yeah, I'm not formalizing it.
Yeah, no, that's clear. And the overlap with other tests, that to me always has been a kind of challenge. Like you're moving forward, your collateral is growing, and it's sometimes difficult to understand. Oh yeah, you've got some overlap there. Maybe not an answer for now, but just mentioning, like, are there some experience-based criteria that you use to make sure that you're always more or less reconsidering or taking into account how much you overlap things?
Yeah. So one of the trips I've done multiple times is move from, let's say, unit test to parameterized test. So it's like the same test by changing the input and the expected output. But then from parameterized test into property-based test, where you define a property and you say this property must be true, and then there's kind of a framework or a library that takes care for you of creating a bunch of inputs. Sometimes when I do this trip, you have this overlap because parameterized tests are covering the unit test, but basically it's syntactic sugar. But then property tests are covering all the cases that you had, or even more, but sometimes you don't know because the values are picked randomly. So what I try to do at the end of the day is that the tests of a feature tell me a story of that feature. So when I finish working on a block, or when it's a good time to do a recap, I like to sit with someone from the team, and ideally the whole team, and go through the test and ask ourselves, do we like the story that these tests tell us? Are we missing a chapter? Is there a chapter that's too detailed? And then I combine that with observability. Let's say maybe we remove some tests, and if nothing breaks in production, we're done. But if things start breaking in production, then we add the missing test. And if that happens too many times, then we have a conversation of, okay, did we miss anything else? Should we be proactive about trying to find the stuff that we missed before our users do it again? So that's the rationale sometimes. Does that help, Luc?
Yeah, that does. There is a question from John, but I first take one on my note, or one of my notes. With the refactoring, of course, how do you know up front? Do you have some gut feeling or whatever, the value of these tests makes sense because of refactoring reasons? In general, it's clear if you're going to refactor and you have tests at hand, that will help you a whole lot and will add a lot of value. But if you had to make a choice, like, am I going to add those tests, yes or no, because of refactoring reasons, it feels for me like you're able to really look into the future to decide, yes, we're going to add them or not.
Yeah. So one way to do that is, well, that happens a lot with legacy, that I work with tests that so with code that has no tests. Okay, and then depending on the change, I judge if it's worth adding the tests or not. So if it's something relatively complex and I think I can fix it with a surgical change, sometimes the cheapest thing is to, let's say, put an if over there and run away, hoping that we will never come back to that code. Other times, it's like you already did 2 surgeries and it's like, okay, I'm sorry, I'm not going to do a third one. I'm going to pay the test debt, and because during the last 6 months we came here 3 times, and again it's a bet because maybe it's the last time you come here, but it's kind of a coincidence that you came here 3 times in the last 6 months. So sometimes the criteria is this one. So I have been here too many times. I'm done with not paying that debt. When I'm creating the code for in the first place, knowing if those tests will be worth or not, here I'm cheating a little bit again, because I try to do TDD. It helps me focus, it helps me create code that's testable, it helps me refactor code, so the code is, I think, nicer at the end of the day. So it has so many benefits that I usually opt for TDD, unless I'm spiking or experimenting a lot and I'm in a place that's super volatile or fragile. Sorry, fragile, not volatile. Like I don't really know if this is going to be worth, so I start with something quick and dirty. But yeah, pretty much a lot of times TDD is worth the effort, and at the end of the day, you have the test for free that will support your refactoring.
Clear. There was a question from John about your assert true, you could say, where he mentioned could be a legit test in a case when an error may be returned before it hits the assert. At least in Business Central, like post sales order, error returned, customer email does not exist. Still, his question is this a valid test, just to have it there to be sure that anything in front of that might be hit?
Okay, yeah, I don't think I know enough Business Central to answer this question from a, let's say, non-Business Central point of view. I would never have an assert true test. Maybe because I'm lucky enough that my infrastructure really supports the fact that I can make tests that are waiting for exceptions. And if the exception is not happening and the test is about the exception not happening, yeah, I don't think I would put the assert true. I would make it clear in the test name or something like that. But yeah, maybe it's very specialized. Sorry if I didn't answer.
Yeah. If John has an additional question, you can put it on the screen. Let's continue.
Okay, so after this conversation, let's try to play with some models, okay? If we take the ideas from before and what's giving us value and so on, or what's reducing the value of a test, we can try to make a new diagram or a new conceptual idea on when to test, okay? So imagine we are creating a test, okay? And we decide that depending on the value we plan to get from the test, so imagine that we have, let's say, more green than red would be a net positive value, and more red would be on the red side. And then we have an effort, okay? If we simplify this model a lot, we have 3 types of stuff, or 5 blocks. The first block is this kind of test that would give you very low value, but also take you no effort or close to 0, okay? If we go back to the getter and setter, this would be the kind of test. And you can say, hey, even if it's so cheap to create this test, I'm not going to do it because it's not the value I'm obtaining, it's not worth the effort, okay? Then there's another set of tests that without a lot of effort give you a lot of value or give you enough value so you want to do it. So in this case, for example, imagine an algorithm that's very complex, but it has one input and one output, or two inputs and one output. I mean, creating a test for that algorithm is super cheap. It's like you create a line, you call the algorithm, you give two parameters, and you say, okay, the result should be X or Y. That's a test. This test is super cheap, and maybe it's protecting you from a lot of value. So that's a test I would be doing. In here, we have tests that also give you more value, but they are a little bit harder to do. They require you more effort, but you still would consider these tests are worth investing in. But at some point, you will cross the threshold and you will say, hey, even for this value, I'm not going to be doing this effort because that's too much. And then, of course, there's a set of tests that, okay, no matter the value I get, I mean, above this threshold, I'm not going to do it because this is way too much. Maybe you have to align with your business stakeholders, or you have to make a big investment up front, or there are some discussions that are off the table, then those tests are not there. And that doesn't mean you will never do them. Maybe over time you will find ways to reduce the effort, or over time you will change your criteria and you will be finding more value out of that test, or you will decide that the value is the same, the effort is the same, but now it's a good moment to make the investment. So these would be, let's say, the 5 categories that I would see. And when do I think we are testing? Well, when we think that the chances of having a net positive value out of a test are worth enough. And when we have nothing else better to do with a better opportunity cost. So this, which seems very simple, in reality is way more complex, because every person in a team can have its own, let's say, chart of what effort am I willing to do and for which value. And also, maybe we do not see that the test has the same value as another person, but also it will change for a person over time, because my personal preferences have changed for sure, and I don't need 1 month to change my personal preferences. Sometimes I look at the problem from yesterday and I change my opinion. Maybe we learn more stuff about the context and we are, let's say, changing the criteria. I think it's important to be aware of these bullet points here in the right, because they can influence a lot in how do we see this diagram. The first one is the skill set. Sorry, I'm going to drink. The first one is the skill set. So a person that's very skilled in testing will think that a lot of stuff requires less effort than someone who's not familiar with that. So a good way to change what and how you test is by improving your skills. The project type. So if I'm in a startup and I don't know if I'm going to eat tomorrow, and I'm pivoting and I don't know if a fitter will be there or not, it's like, okay, I'm not going to make a very big investment on that. I just want to add value here and there, and if I can do it with changing 2 notches, I'm happy. If in the other way around, I'm working with a long-term project sustained over time and mature and so on, then I will probably be happier making bigger efforts or reducing the risk. The third one is risk aversion. Even in the same project, there are some persons who are, let's go to production and we'll see, or we're not going to have problems here. And there are the persons who would be testing everything. No, if you look at the chart of the top, the bottom right, it's like the person who has everything in red is the person who would never be testing because it's not worth, and maybe that person has no problem at all with running risks. Then the mood, as I said, I can change from today to tomorrow. And then the recent findings. If we have been finding bugs for 2 months, one after the other, maybe our risk aversion will get reduced, and maybe we will make a conscious effort to invest more in test or to learn or blah, blah, blah. And then the last one is architectural enablers. There are architectures which make it very easy to test your code, and there are others which make it super hard. So depending on what's your context and the tools and so on, you will be more prone to test stuff that otherwise you wouldn't be testing. So yeah, this is a dynamic in the sense that it can be changing over time for a single person, but is from a team point of view, I think it's a conversation that's nice to have to understand what kind of shapes do the rest of your colleagues have in their head when you're having conversations about what if we test and how far. So if we look at this kind of way of modeling, when to stop? Well, we stop when we do not have any potential test to create that we think will fall into the green area. So when does that happen? Well, imagine the example we have here at the bottom. We start working on a feature, and we have 3 tests, the 3 crosses, the violet, yellow, and blue one. And with that knowledge of the world at that moment in time, we are saying, okay, we think we are going to do, I would be doing the violet and the yellow, but the blue I wouldn't be doing. Okay, we implement the violet. Now it's a different, stronger violet. And you see that the yellow one has less effort and has less value. The fact that the violet exists makes that maybe we build some code that the yellow one will use or some infrastructure, but also the fact that the violet is working means that the yellow one will be giving us a little bit less of information because there are some parts of that feature that we already know that work. And as you saw, yeah, at the beginning we had like half green and half red. The red got a little bit reduced after implementing the first test, and after implementing the second test, we're like, okay, we have these 2 tests, we're reaping this X value out of it. The blue one has even less potential value, but anyway, we cannot think of any effort that it's worth doing because maybe we have enough overlap with the test that we created that we have reduced the value of any future potential test. And if I go back to the list of bullet points, basically, what are the reasons why some tests will move into the red area? Well, some will move because the coverage of other tests reduces their value. Others will be in the red area because the effort is too high. So when they are there, we stop if we only have tests that we don't want to do because the effort is too high. Sometimes the value is very low, like in this volatile environments and startups. It's like, okay, I'm not going to reap value out of it, so I'm not doing it. Opportunity cost is too high. Sometimes there are tests that would be adding value, but we better invest our time doing something even more useful. So we move away and we run some risks. And with the shrug, we have the last one, we run out of time. And why the shrug? Because it's a little bit sad, but it's usually the main criteria. It's like, oh, we've been testing this way too much. Or we are going to test this for 2 days. It's like, why 2 days? Okay, I mean, you will find stuff halfway through. Maybe you should stop before. Maybe you need to add more time. But sometimes because we decided that we would be testing this in 2 days, then we do that in 2 days, and we only move on after the second day has gone by. So yeah, these are reasons that would lead us into stop testing. Okay. Why do I like models? Because sometimes, even though they simplify stuff, they help us understand things, but also because you can use the models to try to game the system and predict stuff. Okay. What this model tells us is that if we are able to reduce the amount of effort we need to create a test, or if we are able to add more value to a given test, maybe we will move a test from the zone where we don't want to do it into the zone where we really want to do it. Okay, and if we go back to the stuff that was adding value to a test or removing value to a test, we can see that we can move this cross by maximizing the blue things, so trying to maximize the things that increase the value of the test, or by trying to reduce the things that decrease the value of a test. And how can we maximize things on the left? Okay, testing things that more users will use, a little bit out of our control, how critical the feature is as well, although we can focus on testing features that are more critical if we weren't doing that before. Facility to find the bug when it breaks. Okay, sometimes you can change the way you write the tests that make it easier for you to find stuff. Test support refactoring and times executed. Well, if we automate some stuff that we were not automating, we will reap more out of this value. And on the orange side, it's like, can we reduce the time it takes us to create the test? Can we reduce the execution time so we execute it more often? And if you have fragile tests, let's say, can you try to look at the causes while those tests are fragile and try to fix them? And in line with those things, there are a set of technical practices that I think add this extra set of value. So first is working in small increments. When you work in small increments, what you are doing is improving the facility to find the bug when it breaks. Okay, because the bug must have been introduced in the small increment you just did, be it a TDD step or a go live. I mean, the sooner you have the feedback, the faster or the easier it will be to identify, okay, it's because of this change, because the change will be small. Breaking the test. Luc, if you read Luc's book, he talks all the time about the fact that the test must be read at some point, so you know that the test is doing something. This is a super cheap strategy to make sure that you do not have one of those tests that cheat on you and give you negative value. If you work with a dependency or third-party providers or with hardware, what a lot of people do is work with test doubles or digital twins. Why? Because you can test a lot of things in memory super quick. Again, we are reducing the response time or the execution time of the test. And this comes with some risks, of course, and you need to do some extra tests to be sure that the digital twin is reliable or works compared to the original source, but that can be done as well. Canary releasing and A/B testing. It's again how to make sure that you quickly find stuff when you break it in a way that you reduce the amount of users that are exposed to it. Sorry. And observability. Observability, to me, it's super curious in a sense that I've seen companies which didn't have a lot of, let's say, automated testing or testing practices, but were very fast at identifying when things were broken in production thanks to observability. So there are multiple strategies that can lead you there. With all these technical practices being shared, I think it's worth to put special emphasis on a couple of things. The first one is no test after TD. So when we have no test, we don't have work, but we do not have value. When we test after, we may have extra work because the test that we introduce may force us to change the code that we already work, so extra work, and the tests are constrained by the current solution. So they are harder to create. When you do TDD, okay, the time to create the test is lower because you write the test when you have no constraints at all, so you can write whatever you want. We can have the test pass as early as possible, so that means we will be running the test more times and we will having this value earlier. The test will be there to enable us to refactor, And that means that we will also reap this refactoring while we're building the feature. It's not about maybe we will refactor in 3 months. It's just we'll refactor while we're creating the feature. And we are reducing the risk of writing an unnecessary test. Sometimes we test after we have created a feature that's not completely used, but still we create the test for that feature that's not completely used. So TDD, sorry, is a practice that really helps you improve or gain more value out of your tests. And the second one that's worth mentioning is the pyramid of testing. And if I apply the pyramid to the model that I shared in the beginning, integration and end-to-end tests were flaky and slow in the beginning when the pyramid was created by Mike Cohn. That was the norm in most of the places, and the tooling didn't support a lot of stuff, or some techniques like digital twins were less extended. And the pyramid had that shape because the value was being reduced the higher you were in the pyramid because of that fragility and that time to execute. But now I've seen in multiple environments that we have less unit tests and a lot of integration and end-to-end tests, thanks to the fact that those integration tests can be run in milliseconds. And that means you have a lot of value because you're covering closer to the user. And if you work in small steps, you still have the benefit of quickly identifying where did you break something. Maybe the test is not super precise about telling what or where the problem lies, but the fact that the test was working 1 minute ago and now it's broken means that you can somehow pinpoint where did you introduce the problem during the last minute, because it's still in your head. Okay, and now what? Now what? A lot of, let's say, criteria, but everything is fluffy. It's just ideas, and this is better than the other, but where's the tangible value? Well, the tangible value is very hard to find, but at least you can try to measure some proxy metrics of the outcome of your bet. So you can identify or count how many times is a test preventing you from introducing a bug, how many times or how often do you refactor your code. The execution time of your test is very easy. And maybe you don't want to measure the execution time, but you want to know if you're not executing tests because of the execution time. And if that happens, then it's worth making an investment or not. The feature usage and revenue, a little bit hard. Time to fix when a test breaks. It's like, okay, this is something you can count. It's like when this test breaks, let's start the timer, and how much does it take me? And if this number is very big, you can work on reduce that number. It will lead you to multiple strategies probably. And the amount of fragile tests. So these are some numbers. Depending on what you want to improve, I would be looking to some of those or others. And if you see that your bets are, let's say, netting you positive outcome, then double down. And if they don't, maybe it's a moment to stop. So, about to finish, sorry, I'm running a little bit out of time. The value of a test is a bet, as everything else, and we don't know, but there are some levers we can play to increase our odds of winning our bets, okay? We can try to make the price bigger, or we can try to make the bet smaller, or ideally both things at the best time. In general, we stop testing when we do not see a bet that's worth our investment, and hopefully you can look at your experience and some numbers to decide how you want to continue and when you want to stop betting. And that's it. Thank you for your attention, and time for questions.
Yeah. John writes, love it. Thank you very much. So that's the first thing to give to you as a compliment.
You're welcome.
There was a remaining question from Arthur. Is there a framework that you build around this that is open source that can be shared? That's his question.
Okay, no, this presentation is all I got. I kind of worked on the idea while on this presentation.
Yeah, clear.
Maybe it will go somewhere else.
Yeah, and it's worthwhile to follow Xavi. You didn't share a link, but I will put it on the recording, a link to your blog, so you can follow him.
Yeah, sorry. because I forgot the shameless self-branding part. I forgot to say that I'm a technical coach 4 days a week for Sunweb, which is a Dutch travel agency tour operator. But I freelance 1 day a week. So if anyone is interested in my services, feel free to contact me.
Yeah. And as you can see on the down left side, you see his Twitter, or what is now called X handle. So you can anyway always find him there. Thanks, Xavi. Thank you very much. I was what I liked a lot is this, the things you brought up as a kind of a structure, which for me relates to a lot of things I've been doing, but making me conscious of yes, I could look at it more consciously this way. So like I asked on how to measure things, and yes, you said it's not measurable as such, but or how you explicitly use this in doing things. It made me more aware of the options I do have. So that was surely making it worthwhile for me. From the compliment from John, it's also worthwhile for him, and I hope it was for many others. And yes, sorry that we went a bit over time, but I think it was good that we concluded it or completed it in the full extent. So what I'm going to do right now is change to my presenter mode. So I get this official slide of thanking you all. Thanks for being here, and especially to you, Xavi. Thanks for picking this up. Ashul will be back to you. I've got a short line, so anyway, I will be. Let's conclude for today. Thank you very much.
Thanks a lot for the invite, Luke. My pleasure.
You're welcome.